I'm Anil Kumar. Welcome to my series on absolute functions. In this video, we'll take up 8 examples based on how to solve equations when absolute functions are involved. Now, absolute functions are also known as modulus functions, right? So both the names can be used. So these are the 8 questions which we are going to solve. You can always pause the video, answer these questions, and then check with my solutions. Here are a few basic concepts which you need to understand before getting into their solution. First is that whenever we are talking about solution of absolute functions with the type of equations we have taken, you will notice that these equations may have 2 solutions, 1 solution, or no solution, right? Normally, absolute function will be given in general. Let us say something like this, right? So this is our absolute function. Okay. Now, if I have something like 7 here, let us say this point here is 3, then we're talking about the very first example, right? Now, if I say x minus 3 absolute graph is this, and we are trying to figure out is equal to 7 means what? Y equals to 7 is a horizontal line, correct? So this horizontal line will be something like this. Now, as you can see, that horizontal line intersects at 2 points. So we have 2 solutions, right? So in this case, we have 2 solutions. Correct? Now we could have something like equal to 0. Equal to 0 means a horizontal line aligned with the x-axis. Now in that case, we have just one solution. Do you see that part? We have only one solution. Is that clear? Now there could be situations where the line may be a negative value. Like for example, we have minus 1 here. Correct? So here, in this case, we have no solution. So whenever you have equations involving absolute functions, you should be ready for no solution, 1 solution, or 2 solutions, right? This is when we have a linear combination with, or a constant with an absolute function. Is that clear to you, right? Well, even if the lines are inclined, for example, if I have something like this, even then, see, we have 2 solutions, correct? So for inclined lines also, we have the same conditions. It could be tangent at a point, right? It could be outside of the range of the absolute function. So we may have 2, 1, or no solution. Is that clear to you, right? So it's very important to understand this part. Now, secondly, you should also understand few basic concepts which we are going to use as rules to solve absolute function equations. So you need to understand that absolute value of x is always equal to absolute value of minus x, right? Both are same things. To give you an example, if I write minus 5 absolute value, it is same as the absolute value of 5, and both are 5. You get the idea, right? Okay. If I have absolute value of x minus a, in that case I could also write this as absolute value of a minus x. Well, these are same things. You get the idea, right? For example, if I have absolute value of 5 minus 3, it is also equal to absolute value of 3 minus 5, and both are equal to 2. You get the idea, right? So this is very important. Second, since we are always looking into a positive value, absolute value of x whole square is equal to x square. On the other hand, if I have something like square root of x square, then that is equal to a positive value, absolute value of x, right? That is not just x. Since absolute function, this square root function will also give you a positive value. So square root of x square will be absolute value of x, correct? Now, if I say that absolute value of a is equal to absolute value of b, then that also means that a square is equal to b square. Now this is a very important strategy, and we are going to use this particular strategy if we have equations involving two absolute functions, right? For example, the function here and the function here, right? So the strategy involved here will be this. You get the idea, correct? Now, I hope the concepts are clear. Let's begin and solve these one by one. The very first example here is absolute value of x minus 3 is equal to 7. Now, that really means that we have two solutions, and this value inside x minus 3 could be equal to 7, or x minus 3 could also be equal to 3, right? 3 could also be equal to minus 7. Since x minus 3 and 3 minus x both will give you the same answer. You get the idea, right? So we are expecting two answers, and both of them can be found by splitting this into two parts. So the same equation can be written as shown here, and they will provide you with two solutions. Here we get x equals to 7 plus 3, and we get x equals to 10. On this side, we get x equals to minus 7 plus 3, which gives you x equals to minus 4. And therefore, we have two solutions here. And therefore, our answer here will be x is equals to 10 or minus 4. Does it make sense to you? You can make a check. If I write minus 4 here, then minus 4 minus 3 is minus 7, and the absolute value of minus 7 is 7. You get the idea, correct? So we have used the concept learned to solve this equation. Similarly, we are going to solve the next equation, right? So exactly the same concept, split it into two parts. So we can say that 2x plus 5 is equal to minus 17, or 2x plus 5 equals to plus 17. Solve both these equations. So we get 2x equals to minus 17 minus 5, 2x equals to minus 22, or x is equal to minus 11. On this side, we get 2x equals to 17 minus 5, so we get 2x equals to 12, or x is equals to 12 over 2, which is 6. And again, we have two solutions, and our answers will be x equals to minus 11 and 6. You can make a check here using these values back into the equation. Perfect. Now when you have a situation like this, since plus 0 and minus 0 is 1 only, so in this case we have only one equation. Does make sense to you, right? Now you should also know that this equation is also similar to writing this with 2x plus 6, right? So both mean the same thing. Perfect. Anyway, if you want, you can change this equation to 2x plus 6 and then solve, or you can keep it as such and make it equal to 0. No problem. So let's keep it as such. So we have minus 2x minus 6 equals to 0, and then we have minus 6 equals to 2x, correct? taking this to the right side and dividing by 2, we get minus 3 as our answer. Is that correct? Now you could have got the same answer with that equation also. Let me just show you. So if I have 2x plus 6 equals to 0, we get 2x equals to minus 6 and x equals to minus 6 by 2, which is again minus 3. So we get exactly the same answer, correct? So in this case, the answer is x equals to minus 3. Is that clear to you? Perfect. Now the last example here is the absolute value is equal to negative 1. Now that is not possible, and so in this case we have no solution. The absolute value is always greater than or equal to 0, right? So it cannot be negative, so we have no solution for part D. So you can see here, we have no solution, we have just one solution, and we have two solutions, and that is what I wanted to emphasize to begin with. Now let's take up examples to practice with slight more difficulty, but again, we are maintaining absolute function and a constant. I'd like you to now pause the video, answer these questions. So here, what will you do? Well, we'll split it into two parts as we did earlier. So we have here 8 minus 2x equal to minus 6, and we also will solve for 8 minus 2x equals to 6. So we have here 8 plus 6 equals to 2x, which is 14 equals to 2x, or x is equal to 14 over 2, and that gives you the value of x as 7. On the other hand, we have 8 minus 6 equals to 2x. This is 2 equals to 2x, and 2 divided by 2 is the value for x, which is just 1. So we get our solution as answer is x equals to 1 or 7, correct? So these are the two solutions. Now we have a cubic equation. Once again, this cubic equation can be split into two to solve, correct? So we'll again solve two equations. So one of these equations will be x cubed minus 14 equals to minus 13. The other will be x cubed minus 14 equals to plus 13. So taking 14 to this side, we get x cubed equals to minus 13 plus 14. So we have x cubed equal to 1. So x is equal to 1, the cube root of 1, right? So you can write here cube root of 1, and so you can write x equals to 1. Clear? On the other hand, we have x cubed equals to 13 plus 14, and so we get x cubed equals to 27. So x is cube root of 27, correct? Which is 3. So we get x equals to 3. And in this case, our answer here is x equals to 1 and 3. Is that clear to you? Right. So first set of questions where we had absolute function with a constant, we're just done. And now we'll take up questions which involves two absolute values. Now how do we solve these ones? Think about it. We'll have a short break and then take up its solution. So the question before you is x minus 2 equals to 2x minus 1. Now to solve this, it is important to note when these two absolute functions are equal, it is kind of like this. We are saying absolute value of a is equal to absolute value of b. So that really implies that a square is equal to b square. And that is a concept which we are going to use to solve such equations, right? So what we get here is x minus 2 whole square should be equal to 2x minus 1 whole square. Does it make sense to you, right? So that is the property. So now let's expand it. We get x squared minus 2ab, which is 4x plus 4, equals to 4x squared minus 2ab, which is 4x, and plus 1, right? So bring all the terms together. So since this is greater, I'll take them to the right side. So we get 0 equals to 4x squared minus x squared, then we have minus 4x plus 4x, and we have plus 1 minus 4, right? So we have 0 equals to 4x squared minus x squared is 3x squared minus 4x and 4x cancel, and that gives you minus 3. Well, that's simpler than I thought. So bringing 3 to the right side, we get 3, or you could just factor this. Factoring is better. So I write 0 equals 2, let's factor 3, right? So we get x squared minus 1, and that gives you two solutions. You could also write this as 3 times x plus 1 times x minus 1, and that gives you two solutions, that x is equal to plus or minus 1. Correct? So that is how we could actually solve this particular equation. Is that clear to you? Right? Now, if you look into it graphically, you could also see something like this. Sometimes we may use graph to solve them. So it's a good idea to just, since we have this space ready for us, so we could graph these equations. X minus 2 means the absolute function graph has been shifted 2 units to the right, right? So let's say that is our x minus 2. And the other function here is 2x minus 1 that has been shifted to half, right? So, and stretched vertically, something like this, right? So somewhere here and stretched vertically. So it's much sharper. And when I use x as 0, we get a value 1, right? So it is going here. So it is kind of much sharper. It is less like this. So you can note that it has two solutions, and these are the two solutions which we just found, and it seems that these values are at minus 1 and at plus 1, correct? So that is how you could also solve it graphically at times. Is that okay? But at present here, we are just focusing on algebraic solutions. So that gives you a visual look at just what we did. Now here is the very last question. I'd like you to now pause the video, answer this. Again, the property being used is absolute value of A is given to us as equal to absolute value of B. Both are equal. So that really means that A square should be equal to B square, correct? So let's do it. So we have 2 minus 3x whole square should be equal to x minus 4 whole square. So let's square this. So when you square this, we get 2 square, which is 4, minus 2ab, 4 times 3 is 12, x, plus this square, which is 9x square. And on this side, we get x square minus 8x plus 16, correct? That's what we get. Now bring all the terms together, 9x squared, bringing this x squared, I'm arranging the like terms also, minus 12x and plus 8x. And here we have plus 4 and minus 16 equals to 0. So that gives me 8x squared, and this is minus 4x, and here we have minus 12 equals to 0. So I could factor 4, right? So we get 2x squared, and then we have minus x, and here we get 3, negative 3 equals to 0. Now 3 times 2 is 6, so I have to split x into those two components, and we could write this as, let me just go a few steps more to factor it further. So since 6 we are looking for, 3 and 2, we'll split this into minus 3x plus 2x, and we have minus 3, correct, equals to 0. Now let's factor this. We get 4 times, let me use this. We can take x common, so we get 2x minus 3. Here we already have 2x minus 3 equals to 0. And now let me take it on the right side to complete and write down the answer. So we have 2x minus 3 as a common factor, so we get 4 times 2x minus 3 as a common factor, and what we get here is x plus 1, right? So we get x plus 1 equals to 0. So that is, we have 4 times 2x minus 3 times x plus 1 equals to 0. Now we have two solutions here. If I write 2x minus 3 equals to 0, that means x is equal to 3 over 2. And for x plus 1 equals to 0, x is equals to minus 1. So again, the two solutions are x equals to 3 by 2 and minus 1. Does make sense to you? So that is how you could actually solve all such questions. So I hope now you understand how to solve equations which involve absolute functions. Remember that it could have two solutions, one solution or no solution. And if you are involving two absolute functions as shown here, the best way to do is to use this particular property, which is absolute value of a equals to absolute value of b, means that a square is equal to b square. So that should give you the solutions. I hope it makes sense. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.